Hello, everyone. I'm David, and this is my talk about Strangecode, or how I learned to stop worrying and love refactoring. The title might remind you title of a Hollywood movie from the 60s, a Cold War classic from Stanley Kubrick, Dr. Strangelove. It's not by accident. You will see some references inside if you know the movie. At the start, it's really good to be here again. Last year, at Ruby Russia 2008, I've been here as an attendee, and I was convinced by some people to be a speaker this year. This is me, just showing. That's me, you should know. I'm from a Hungarian-speaking part of Slovakia, living in the Czech Republic, which means I kind of understand you a little. I live in a town called Brno, which is famous for beer, MotoGP, and weird sculptures like this, which is a clock. This is a guy stealing your washing machine, and a horse with really tall legs, which is even more bizarre if you realize that they are standing towards each other. I also have a dog. It's a new thing. It's a few months old. His name is Bruno, and he looks like this now. He's growing. And I would like to take you back to the history, to 2010, when I started studying computer and embedded systems. I graduated as a hardware engineer, and I realized I don't want to do that for money. In 2012, a friend of mine gave me a book, this one particularly. It was a Rails for Dummies, where I learned how to master the world of Rails. I became a senior developer in just a few months, senior in using these two commands. It's awesome. Then I started interning at a small startup called Red Hat. You probably heard about it. I wasn't doing Ruby, but because I loved open source, I stayed for a little longer, and after a year, I upgraded myself to a Ruby engineer, started working on a project called ManageIQ, which is an application, an open source application for managing clouds, hybrid infrastructure, virtual machines, and containers. Basically, if you have a cloud, we can manage it. We support a lot of platforms. It's really worth to try if you have a huge infrastructure. You might recognize the logo of ManageIQ because I gave out a lot of stickers last year. You see the happy organizers here giving them out. So at the start, a brief history about ManageIQ. It wasn't a Red Hat project. It was a separate company founded in 2006, same year as Twitter. It was a startup, so it's rapid growth, you know. It's still actively developed after 13 years. No rewrites, it's just incrementally growing organically. The project name was Enterprise Virtualization Management for managing clouds and virtual machines. It was launched in 2007, and the most important part is it was written in Ruby 1.8.6 and Rails 1.2.3. And as I said, there were no rewrites, so it was growing, and we kept it upgrading. Red Hat acquired ManageIQ in 2012. In 2013, it made open source, and I started working on it in 2014 in the UI team. And you would ask this question, what a UI guy is doing in a Ruby conference. Ruby isn't a front-end language, but as we will proceed further, you will see that there is place for Ruby in the UI team, especially with a huge code base. So I was really excited. I really wanted to do a great impact, so I did git clone, and what I saw wasn't really impressive at first. I did the statistics from the lines of code. Here you can see how many lines of code each file language has. I will zoom you in the bottom right corner. This is the number. This is the number of lines of code in our code base, and I was like this. Just for more dramatization, it's 1,200,000, I don't know how to read, some more. You would say it's a monolith. I say it's a megalith. And before we go deeper, I would like to talk about startups. In a startup, you have a little different development model because you don't have time and you need stuff very quickly. So you don't care about stuff like code quality that much. You definitely don't care about scalability because you can just implement it later if you really need it. So you do a lot of hacks. You do a lot of anti-patterns. You don't really write tests. You introduce a lot of technical debt. It's about trade-offs. So you have these trade-offs to keep your investors happy and get to the market as fast as possible. And it's totally fine in most of the cases because you are working with limited amount of time and money to make a great impact. So if you're developing a software, you have something like this. So if you're growing your project, you have a hut. From a hut, you're growing it to a house, and then to a bigger tenement. So you do some architectural changes. However, if you do a startup, this might happen. So your technical debt, your hacks make it a little complicated. These illustrations were stolen from Ivan Nevichenko. I really thank you for that. He writes a book about how can be Rails developed painlessly. You should check it out. Thank you, Ivan. So adding features to this kind of monolith or megalith is like Jenga. So you add a new feature and you don't know when it will crash. And I would like to also mention the theory of broken windows. So if you have a house with a broken window in a neighborhood, there is a much higher chance that a next window will be broken compared to a house which doesn't have a broken window. It's simply because you don't care that much about bad stuff if you want to proceed. Of course, back in those days, as a naive developer, I seriously had no clue about this stuff. I was just frustrated. So it wasn't really happy. I really wanted to have a great impact. I really wanted to use my Rails generate skills, but what could I do? I did the job they told me. I made a new branch. They told me, a senior developer told me to convert some views from ERB to HAML. I had no idea why, of course. So here is the very first file I opened, which is an ERB view. And you can see there are a lot of problems with it. It was made in a hurry. You have a for loop with really bad indentation. Then you have another condition with an unclosed tag, so you can have invalid HTML, possibly. Then you have some conditions inside, which should live maybe in a helper or in the backend. And then you have a closing tag, which is not really idented with the opening tag. Then you have a closing tag again, which can produce invalid HTML with some arithmetics. And my special favorite is this, where you have to actually comment where is the end of the original for loop, because the code is so complex. So based on this, after years, I'm able to, with my experience now, I'm able to create a list of these problems. So we have mixed steps and spaces. That's not visible. I'm sorry, I didn't want to visualize that. Indentation is inconsistent. Sometimes we can have invalid HTML. The presentation logic in general is complex. We have blocks with do and end. That means you need closing tags, and you might forget about it. We might have possible dead branches. I don't know. In general, it's hard to read. And after some time, I realized that by just applying HAML on the view, it becomes much easier because it's a systematic solution that doesn't allow you to write bad indentation. It's something like Python, but for the front end, which I didn't know Python before, but if I would know Python, I would have been referencing to it that time. So I did a small systematic change without me knowing it, and it made a great impact because it improved our code base a lot. So I was basically rewriting our views, which was a lot, in 2 months, and I became top contributor really fast. So if you remember the code, this is the original version. Just for the record, it displays 3 checkboxes in a row in a table. So you have rows in a table, and each row has 3 checkboxes. And that's why you need that crazy arithmetics. And rewritten to Haml, it looks like this. Pretty simple, right? So instead of doing the arithmetics, I utilized each slice and row each. So there are 2 loops instead of 1 and arithmetics. And you don't need closing tags, you have strict indentation, everything else is the same. So all the stuff from the previous slide was just for these 2 loops and the bad indentation. So these systematic solutions can be really great impact. And at the very beginning, it really helped me a lot to become top contributor, for example. Most of the stuff I did was just doing things the Rails way, which in our case meant not doing things in the Rails 1.2 way, because we had a lot of old stuff which wasn't converted. For the record, I deleted the CGI bin directory. Before the rec, or like the old version of Rails, it was using CGI bin. I deleted it 3 years ago. We were using like Rails 4 or something. It was totally unnecessary. Of course, we had a goal to have, instead of a megalith, some kind of microservice architecture. And in the front end, we wanted to have an API-driven single-page application. That's the eventual goal, but we are not there, and this is the reason why we aren't there. It would take us years to rewrite everything. So how would we do it? Like, people would go crazy trying to find a universal solution for that. And the answer is small steps. So I'm not going to show you big steps, just really small ones. There are some other architectural patterns which weren't the new Rails way. So we weren't utilizing the asset pipeline properly. So we had a Rails static file server serving all the files, which is slow. We weren't minifying, we weren't compressing. We've been using 2 JS frameworks, Prototype, which was used in old Rails, and jQuery, which was used from Rails 3, I guess. And we had a lot of third-party dependencies, mostly JavaScript, in our repo. And some of those could be fixed really fast, just like crossing it out. I mean, turning off the static file server, turning on minification, turning on compression, deleting Prototype in favor of jQuery, these are really, really simple fixes. For the third-party dependencies, we were really investigating into solutions. And the very first one was Rails assets. Maybe you used it, it's not so popular now that we have all those new shiny JavaScript package management tools. It was a Ruby gems source, which contained all packages from Bower. So you could just specify a different, I hope it's visible, yeah. So you could specify a different source for Rails assets, and you could use any kind of JavaScript package, and it was magically appearing in your asset pipeline, and you could just use it. Which was really nice at the very beginning until we weren't customizing packages. It was slowly synchronizing with Bower, and if we created a new package, we wanted to be compatible, and it took some time to convert from Bower to Rails assets automatically. Also, they had some hosting problems. I checked it right now, they are working, but back in those times we had issues. So we had to introduce Bower, which you pull in something for managing your dependencies, fine. But of course, not all packages were available in Bower because Bower became less and less popular because there was a new cool thing called NPM. So we were using 2 package managers for the front-end dependencies. Then NPM wasn't cool enough because it didn't have a package lock, so our JavaScript devs went to Yarn. Thankfully, at this point, they made a great choice by getting rid of Bower and using everything from Yarn. So there were some packages that had to be converted, like completely. We had to publish the Yarn version, and we are still maintaining it. At the end of the day, we support both NPM and Yarn because now they are fully compatible, so it doesn't matter what you're using. So that's the story of our front-end stuff. So we had another technical depth, like server-generated JavaScript. We had anti-patterns in our forms, which were really good idea, like 10 years ago maybe. Like each on-change generated an AJAX request. which was sending all data to the session. And when you were submitting the form, you were actually submitting the empty form, and data have been taken from the session. This doesn't really allow you to have more than one tabs open because you depend on the session, and if you have the same forms open twice, you can invalidate the data. But back in the day when tabbed browsing wasn't a thing, this seemed like a cool idea because you could validate everything in the backend. We had a lot of presentation info stored in the session, like which page are you on, or the previously mentioned forms. We had a lot of duplicate code, which was duplicated. We had views tangled into each other, and also a lot of dead code. And these problems, like the last three at least, could be solved by brute force. And by brute force, I mean you could go through all the files one by one, checking it. You need really motivated people to do that. Then the rest was a little harder. So if I color it like this, you will see that the server-generated JavaScript was being used for the on-change events, and the session is utilized both for the forms and both on the whole page. And we started asking people from the front end what could we use instead. So they said, just use AngularJS. You will do the validation on front end, you will have your API, and everything's cool, right? Then another guy came and said, we should use Ember.js. You can do the same, but cooler. Then they said, we can use Vue.js. And then they said, AngularJS is not cool anymore, you should use Angular. But Angular is not cool anymore, so you should use React. So we were stuck in the framework hell. And we had our fights about which framework we should use. It was a long run because I told you the number, the 1 million plus lines of code. It takes us months or years to rewrite everything. So for some time, we have to maintain the old code and the new code simultaneously. Which is not nice. So we wanted a really systematic solution. We went with AngularJS at the beginning because that time wasn't really anything else that good in 2013 or 14, I'm not sure. At Red Hat, we have a UX framework called Patternfly, which at the very beginning was Bootstrap, some sugar and widgets around Bootstrap. Basically, something you would call now them components, but that time were just widgets that you could use. They were unified looking, and all our projects should use them or are using them. And at the very beginning, it was implemented in jQuery, but because people started using frameworks, everyone started implementing their widgets in their frameworks. And if you see at the contribution graph, some people were using Angular, some people were using React, some people were using Angular 2, and the popularity was varying, and we had issues with some components not existing in Angular, but existing in React. So we were still stuck in a framework hell with the danger of having multiple frameworks in our code base. And we went back to the problem and we made 2 steps backwards, and we looked at all those frameworks and we realized that we need just 2 things. We need components, those isolated little elements, and we don't really care in what they are implemented. And instead of the session, we would like to have something called a global shared state, which would replace the session eventually. Our choice, and thankfully other projects' choice in the Patternfly ecosystem, was on React and Redux. I'm still a little skeptical about it. Right now we support both AngularJS and Redux and the old code. The global state is not really utilized yet, but we are moving towards it. Things like which page are you on, which tab is selected, it doesn't have to do anything in the backend anymore. Of course, we have a backup plan. 70% of our apps are forms. I'm not sure if it's your case, but in our case, we have a lot of forms, which is specific. Might be specific for us. We can discuss about it later. And thankfully, we implemented something for dynamic forms. So we offer a feature for our customers to generate forms, build with a drag and drop feature forms, and then render them. And we already had a JSON schema for it, which is actually similar to the one Mozilla implemented for forms. So we put together the two and came out with something like this. And on top of this schema, we implemented a renderer, not me, but other really smart people, data-driven forms, which takes this JSON schema and it renders to a form. And it can render it, this is pattern-fly, but if you flip a switch, we have component mapping. We can render it to Google's material with a single flip of switch. So it's a really powerful tool, and it allows us to be more prone to errors of frameworks. So if React wouldn't be a thing, we just re-implement data-driven forms into a different next cool framework, and we are done. Our forms are in JSON, we don't care. I really suggest you checking out. It's a brand new project, a few months old. We are happily using it. I personally implemented a drag and drop editor on top of it. Thanks to it, it's just React components. I just did a wrapper that implements drag and drop, and you can design your forms. So enough from the JavaScript part. I'm sorry about that. Here is a picture of my dog utilizing the kennel. He doesn't know how to sleep inside. And I would like to talk about stuff I was working on in refactoring. We have in our project icons. You know, these small pictures that you have mapped, ideally mapped to database object or something else. Here you see them in action in tables. And the code for these icons was like this. So you have some data fetching, then you have some case, and based on that case, you return something. And inside of the case, someone came and wanted to implement new icons, so they added it. Or there are other kind of conditions which don't return anything, and someone optimized some file names, so we don't know what goes into the else branch here, because it just calls viewdb._. It's a mess. And as I said, it's like the Jenga if you want to add a new icon type. And I made a step back, and it was basically a mapping from a database record to an image. And if we turn it around, it's basically we could declare the image in the icon. We could declare the image in the record, in the model. And I went after the backend team, like, hey, backend, could you please allow us to declare icons in the backend? And they said, no presentation logic in the models, which is fair from them. They don't want to care about our assets. So we went to the different approach by wrapping models with presentation logic, or instead of wrapping, I could say decorate, if we talk about patterns. So using the simple delegator, we implemented a decorator that wraps around database models. There is a loop that searches for, in the single table inheritance, it searches for the right decorator for the right model. Then we call this on models, so we just implemented one method in each model that gets you back the decorator, the decorated model, the record. And in the decorator, we were implementing these icons. So instead of the case, the big case, all the logic is done by just object inheritance. And you can get that icon by asking for record decorate file icon. And if you want to change the file icons to CSS classes, you just add the new method font icon. This is basically what we've done. We have something called Quadicons. This is for like a tile view where you want to see like data stores or VMs or whatever. Here you see data stores, you see the provider, how many files it has, the free space. It contains more information. The code for this was similar. We have some inline styling, and we have some if-else-if that loads some partials. For data stores from the previous example, and then we render that partial. For the data store, we have this specific partial. It's even too big. It has scroll bars. Sorry for that. It has some icon lookup again, which we already implemented, some other icon lookup based on some condition, and another icon lookup just for fun. It's basically the same icon, but it's tangled into that. So we went back to the decorators and just implemented a simple JSON schema. Here you see the quad icon, which you declare what's on top left, top right, bottom left, bottom right with text and tooltips. We also have a fallback for smaller screen where you just show one icon, which is a pie chart in this case. Basically, it's a pattern of having a JSON and a component. And we kind of use it for all our models, which are displayed visually. This JSON and component pattern has been also used elsewhere, or will be utilized elsewhere. We have menu. I guess everyone has a menu, and they have ways to declare your menu. We had case switch statements checking for roles and if the user is allowed to open the menu. We rewrote it to something like this. It's actually a structure in a structure where you have the feature, and the feature is evaluated automatically upon render time. Then you declare the default menu, what sections it has. It's pretty straightforward. Then another thing I've been working on are trees. And by trees, I mean these things on the left side. If I go back, yeah, it's on the left side, it's zoomed in. It's a hierarchical structure. We have folders, at least for VMware. If you have virtual machines, you can organize them to folders. So we wanted to show the same folder hierarchy. Of course, we have screens where you have more than one tree. We organize them to accordions. And we use the same pattern to describe those accordions into nice structures instead of those crazy if-else case. I would like to show it to you, but it wouldn't fit on the screen. I'm sorry for that. So this is the code after the refactoring. And our trees in particular were a recursive structure. So we were building it recursively, getting the children of children from the root and from any node, actually, because we support lazy loading if you have like a lot of elements and you want to expand them. Nodes have been added from the views, from the controllers, and some special presenters, which is a mess. So you don't want to have this kind of data flow. And nodes have been created from DDB records and static hashes. And at the end, the structure was converted from objects to hashes. Those hashes were organized to one big hash, and that hash was converted to JSON that was being rendered on the page. Instead of that, we got rid of the views and the controllers definition, and we moved all our stuff into an existing pattern, the tree builder, and we convert the objects directly to hash. So we just did some data flow changes. Code-wise, the three nodes have been built like this. This fits on the screen, so I chose this. This is a big case where you check what kind of object is, and you render the node. Instead of this, we had no decorator pattern implemented that time, so I created a wrapper object that implements the same stuff as the decorator, actually. And then you call this node. I implemented a DSL for declaring that node, but it works, of course. But it was a bad idea because I wasn't utilizing the decorators. I didn't know about them, that someone else was doing them at the same time. But I would like to see it will be eventually converted to the decorators, I think. There is a pattern here. There is a declarative solution of declaring big structures with JSON and a component. We use decorators for icons, quad icons, and let's say tree nodes. We use struct-like objects for more static stuff with like toolbars, menus, and tree builders. And eventually we want to use JSON files for our forms. Some of them already have DSL. Some of them might have it in the future. Basically, we are going from the old if-else spaghetti generating HTML plus JavaScript to decorative generating JSON, structured generating JSON, and just having plain JSON in our code base because it's much easier to maintain. Eventually, everything with DSL, or we just rewrite it to JavaScript. I don't know it yet. The front-end part is evolving. Who knows what will happen in years. And when it's no pattern, when you can do smart choices like this, then For example, like this kind of code, which is data manipulation. It's kind of long. It's not scrolling, I'm sorry. It's kind of long. I need scroll bars. I will go through the code in the next slides. Then you have to go the hard way. You have to go to the experts. You have to read books like this about how to do refactoring, go through it, sit down, and do small changes and fix it. There is no other way. So for example, in this code, this generates a tree-level array structure. I will show it in the future. I will just show some highlights. There is a big if-else statement in the middle, which either loads default data or generates new one. Then there is a global variable, and we push into that global variable. It didn't jump, I'm sorry. Yeah, and then alter that global variable at the end, because why not? It's really bad data flow. Then we have another global variable data that we use only for 1-2 lines, which is totally useless. We have helper variables, because why not? Just adding to an array and then not using the array at all. And the whole thing is that it generates, and we add some custom things, custom reports in a really tangled way on 2 places here and also here. It's the same code, just written differently by probably a different person. And the whole thing, the whole tree-level array is built by a structure, a string structure, 3 strings concatenated by hyphen, and we split it up, and then we build a structure using these pushes. You see title 1, title 0, title 1, title 2 being pushed into the structure. It's kind of crazy. Basically, I said it's a tree-level structure. It's a report menu. It has folders, and the folder has reports. It has a main if-else statement. We have the custom reports on demand. And yeah, it's complicated. The structure is taken from the string. This is the format it returns. The indentation is, I think, a little messy, but you get the idea. This is how it looks like visually. If it's visualized in a tree, it's not actually a tree, but that's what I found for visualization. And after refactoring, it's just 35 lines. So the if-else has been changed to a separate method, the default reports menu, which if the first part isn't available, you fall back to the default reports menu, which is basically a simple SQL query getting you the data into the right format, and you do the split for the string, and you use enumerable methods like group by and map to have that structure from your previous slide. Then you have the custom reports, which is wrapped into an unless it's an extra query and pushes data into that. And then we'll return the reports. I think it's pretty simple compared to the original one. There is a problem. Created this PR in 15th of January. It was a single commit, and it has been merged on the 9th of February. It took someone 3 weeks to review it. You shouldn't do that. You should do small steps. You should document those small steps so people can actually review it. Because then you can write really great code, but at the end of the day, someone needs to review it for you and merge it, at least in our world. At the end, I would like to say that no one likes bad code, or at least I'm hoping no one likes bad code, and no one wants to write bad code. I'm an idealist, I know. I hope there are no evil masterminds who want to write bad code intentionally to make other people's life painful. So how bad code happens? If you think about these reasons, like, I need this by tomorrow. I don't want to do this. I just want to get paid. I don't know how to do it. I didn't see how to do it. And if you focus on these reasons, you can be much better. I mean, if you're not working on a startup when the time pushes you. There are some other takeaways I would like you to know. Rome or Moscow wasn't built in a day. So you should set a high-level vision, a target, a goal, whatever. Take small steps. avoid premature optimization like I did with the DSL. You cannot really save the world in one day, so you have to actually use those steps and show them to others when they are reviewing it. You shouldn't be afraid of dropping bad patterns like I didn't do with DSL for the trees. Adding complexity for future gain, if you know that complexity will go away and you can convince the people to actually merge the stuff for you. I'm struggling with it sometimes. You can use systematic solutions, but not always. Sometimes you have to use brute force, and sometimes you really have to think. So please set a goal, make small steps, know your patterns, try to be declarative because it's easier to read, easier to maintain. Thank you.
Okay, thank you, David. I think we have... Ладно, по-русски. О, у нас даже есть вопрос. Okay, we have one question. Can you... Okay.
Hello. I have a question about JSON. You said that you have all these different structures and you make them look as a JSON. How do you render JSON on the client?
With components.
Is this JavaScript?
Yeah, it's a front-end technology. I didn't want to go into the details.
Thanks.
Okay. Any questions? Maybe one small question? No? No.
I actually have one more slide. I was expecting someone asking for tests, and no one was asking for tests. Never mind. Find me later. I have some stickers like these. I have some check candy. I'm really willing to talk and discuss about stuff in technical depth.
Thank you.